So let us write note. First point, medium. Medium means this is the medium. This is medium, like that. Or material. Material means like wood, lakdi hai, like conductor, like plastic, etc. So medium or material parameters. Okay. So any medium or material is characterized by three parameters. Those parameters are epsilon, that means that is the permittivity, unit is farad per meter. Mu name is permeability, unit is Henry per meter. Actually, permittivity means ability of the medium to permit the electric field. Permeability means ability of the medium to permit the magnetic field. That is the meaning actually. Now sigma, it is conductivity. The meaning is ability of the medium to permit the electrical current. That is the meaning of that conductivity. So it is mho per meter. Okay. Now this these are the three parameters. Now here let us discuss one by one. What is the meaning of linear medium or otherwise material? Doesn't matter. Medium means material. For example, this is air medium or otherwise air material. So this is wood medium or otherwise wood material, like that. So linear medium. If the medium is linear. Linear means what, student? Y is equal to mx straight line equation. If the medium is linear, then epsilon comma mu comma sigma are otherwise then medium, then that medium, right? Then that medium follows three equations. With this one equation comes d is equal to epsilon e. It is like y is equal to mx. Then with this you get one other equation b is equal to mu h. And with this you get j is equal to sigma e. Of course they are vectors, so here also they are vectors actually. And then if it is non-linear medium, then these equations are not valid. But in the electrical engineering or electronics engineering, inside capacitor, inside inductor, inside resistor, like inside transistor, generally whatever materials we use, they are all linear mediums. That is why we use these equations. Okay. So if the medium is linear, then that medium follows this equation follows d is equal to epsilon e, then b is equal to mu into h, then j is equal to sigma e. What is the meaning? If it is a linear medium, then you apply the electric field E bar is equal to 2, for example. Then how much D bar is produced? Then that is calculated by using this equation. If it is non-linear medium, then this equation is not valid. So that is the meaning of that. So then that medium follows equations, follows these equations. Okay. For non-linear medium, above equations are not valid. They are not valid. Next, I told you in our devices most of the materials are linear. Now, third statement. Iso means same. Trope means direction. So isotropic medium. Students, you come and stand here. In this air medium, in this direction epsilon value is epsilon naught for air medium. In this direction also epsilon naught only. In this direction also epsilon naught only. In any direction for air medium, epsilon, mu, sigma values do not change with the direction. That means they have same values with direction. So that is called isotropic medium. For example, you take crystals. In crystals, direction to direction, epsilon, mu, sigma values changes. For example, in a crystal, epsilon becomes a matrix. Epsilon x component in x direction, epsilon x component in y direction, epsilon x component in z direction, epsilon y component in x direction, like that. In crystals, these values change from direction to direction. For example, you take any diamond. In particular directions, it shines more, चमकता है ज़्यादा. कुछ directions में चमकता नहीं है. इसका मतलब है उसमें direction to direction properties जो है, ये values जो है change होता रहता है. उसको बोलता है non-isotropic medium. So like air medium, wood medium, direction, epsilon, mu, sigma values are in any direction they are same. That is why they are called isotropic mediums. So, isotropic medium. If epsilon, mu, sigma values does not depend on direction, then that medium is called isotropic medium. For non-isotropic medium, epsilon, mu, sigma values change from direction to simply write it, change with direction. Values change with direction. So iso means same, tropo means direction. Isotropic means values are same in any direction. That means values doesn't depend on direction. But for non-isotropic medium, these values change with the direction. Next point. Homo means same. Genus is Greek word. These are Greek words. Genus means type. Same type of medium, homogeneous medium. That means At this location, epsilon value for air medium is epsilon naught. At this location also epsilon naught. At this location also epsilon naught. At any location epsilon naught. Then values are same at any location. That means epsilon value doesn't depend on x comma y comma z. So that is called homogeneous medium. For example, you take a wood, you take a tree, पेड़ लीजिए, पेड़ को सेंटर में hardwood रहता है, that is hardwood रहता है, then one more layer whose age is less, and one more layer, wood layer. In this wood layer, here properties are different. At this location, properties are different. At this location, properties are different. Here, in this central portion of the wood, lakdi, density is very high because वो बहुत पुराना है, उसका एज बहुत है. So outer most layer है, उसका डेंसिटी कम होता है, उसका एप्सिलॉन म्यू वैल्यू सिग्मा लोकेशन टू लोकेशन चेंज होते रहता है. एग्जाम्पल I told you. So dear students, homogeneous medium, if epsilon mu sigma values are independent of x comma y comma z, then it is called as homogeneous medium. That is epsilon mu sigma are constants. So they are actually constants for this medium. So for non-homogeneous medium, epsilon comma mu comma sigma values change. Values are functions of xyz, you can write. So values are functions of x comma y comma z, you can write like that. Okay, these values are functions of x y z. That means they change location to location. Then what is the meaning of simple medium, dear student? What is the meaning of simple medium? Fifth point now. What is the meaning of simple medium? So actually any medium follows linear property, and that is isotropic, that is homogeneous, then that is called simple medium. So if the medium is linear, isotropic, homogeneous, then it is called as a simple medium. These are all definitions, students. Now next one, non-dispersive medium. In any medium, epsilon mu sigma values doesn't change with frequency. For example, we will send radio 98.3 megahertz. Then we send a satellite signal of 4 gigahertz. In both the cases, this air medium offers same epsilon mu sigma values. That is why that air medium is non-dispersive medium, like that. In any medium, if frequency changes, then epsilon mu sigma values of that medium changes, then that is dispersive medium. So non-dispersive medium. If epsilon mu sigma values does not does not depend on frequency, then that medium is non-dispersive medium. It is non-dispersive medium. If epsilon mu sigma values depends on frequency, then that medium is a dispersive medium. That medium is a dispersive medium, dear students. Then that medium is dispersive medium. Okay, dear students. So these are the definitions. You have to remember them. They are not of explained you. You have to remember them. In the uniform plane wave chapter, at the beginning, we will take medium is linear, isotropic, and homogeneous. There you should not confuse. You have to revise them. Okay. Okay. This is all about the medium parameters and types.
So actually, students, for GATE students, static electric field and static magnetic field chapter is not there. So after covering the coordinate system and curl, divergence, gradient, Laplacian operator formulas, directly you have to go to the Maxwell equations, time varying fields and Maxwell equations. But what I am doing, in between, I am giving some lectures in static electric field and static magnetic field, so that you will learn some basics of static electric field and static magnetic field, so that smoothly you can go to the time varying magnetic fields. Because suddenly, without discussing static electric field and static magnetic field, suddenly going into the time varying fields, then you will be little bit uncomfortable. So that is why no need to cover entire static electric field and static magnetic field. Only few lectures are given in static electric field and static magnetic field, so that you can smoothly go to the time varying electric field and time varying electric field and Maxwell equation. So in that way you need not to worry that हम लोगों को भी स्टैटिक इलेक्ट्रिक फील्ड स्टैटिक मैग्नेटिक फील्ड पढ़ा रहा है, ऐसा फील मत हो जाओ, क्योंकि थोड़ा सा पढ़ेंगे इधर उधर आपको फील आ जाएगा, सडनली जंप ना हो इससे उधर. बट लेकिन आपको गेट सिलेबस में इस बार तो निकाल दिया वो, इसलिए थोड़ा स्मूथली ट्रांसफर होने के लिए थोड़ा सा पढ़ाया उसको. राइट स्टूडेंट्स? ओके. So students, in the workbook I am writing the questions. You don't bother about the question numbers. You see the question and you think of the solution. So you don't search for the question. Okay? The question numbers may be changed. So that's why you don't bother about them. After concept, I am teaching you the questions associated with the concept. So you will not have any problem.
Now, static electric field. We have completed the basics, but you have to revise the basics minimum 3-4 times. Everything you have to learn in the basics. Then the subject you can understand very easily. Okay, dear friends. Now, static electric field. Non-moving charge or otherwise static charge is the source. Source is also called as cause. Source of static electric field. So wherever a charge is there, automatically that is non-moving charge, then static electric field is generated. Static electric field means electric field equation is not a function of time, but it can be a function of distance. There is no condition on distance. Now, types of charge sources. Types of charge sources. First one is point charge. Point charge means like this. Q is there at single location. So this is the example. Example like a single electron, single proton, or otherwise you take a small conductor ball and rub that with woolen cloth. Then on that small conductor ball, the positive charge is accumulated. These are all examples of point charge. So here Q is simply charge. So the unit is coulomb. Okay, that is one type. Second type, line charge. If charge is distributed on the length, for example, transmission lines, this is conductor, this is also conductor, then if you connect voltage like this, then here positive charge comes, here negative charge comes. This charge is distributed. Distributed मतलब हर जगह में है वो charge. What I mean. So, like on a line, if there is a charge, then that is called line charge. But that charge is not at single location. That is distributed at every location on that line. So, if you take a line like this, then let us say at every location charge is distributed like this. Okay, so charge is distributed like this. Then let us say total length of the line is L. Total length is L. Now on this line, total charge is equal to Q, let us say. Total charge is Q. So now let us select a very small length here called dl. So if you select dl, then in total length q charge is there. In dl means small length. In small length a small amount of charge is there. The symbol is dq. dq means differential charge, otherwise small amount of charge. Now rho L is the symbol for line charge density. What is the definition of this? Limit del L tends to 0. Limit del L tends to 0 means you take very small length. That is the meaning. For example, dl is small length only. So in del L distance, del q charge is there, that means very small charge is there, and the charge unit is coulomb, and delta L length unit is meter. So I told you per meter square, per meter cube, they are called densities. Per meter means line density, per meter square means surface density, per meter cube means volume density. So this is also written as this is dq charge, that means small charge in dl distance. So that implies dq is equal to rho L into dl. This is one formula. What is this formula? Anywhere given rho L equation, then you multiply with dl with small length, then you get small charge. Then if you want total charge, then here dq charge, here dq, that means you have to add them. Adding means integral. How many integrals? Single integral, because the line this is. So total charge Q is equal to integral dq, that is nothing but Q is equal to integral rho L dl. This is another formula. So this formula is used if rho L equation is given and then you have to write dl equation, then you integrate, you get total charge, where Q is total charge I wrote. Here I will write this as equation 1. Equation 1 is used to find total charge, that means Q, when rho L is non-uniform. I already told you this one, every time we can't discuss. Non-uniform means, for example, rho L is equal to 2x square coulomb per meter is given in the exam question. That means rho L is a function of x, means it is non-uniform. You have to put inside the integral and you have to integrate that. In any question, rho L is equal to 6 is given. That means it is a constant. Then no need to put rho L inside the integral. You can get that rho L outside, then integrate dl. Then rho L into integral dl means total length. Total length it becomes. So this is another formula. When this formula is used, if rho L is uniform. So already I told you, whenever physical quantity is non-uniform, then that should be inside integral. If physical quantity is uniform, that should be out of the integral. So here I am writing if rho L is uniform, already you know the meaning, I already told you, you have to revise them. So if rho L is uniform, then total charge Q is equal to rho L comes outside integral dl, that becomes rho L into total length. So in this case, Q is equal to rho L into total length. So where rho L is line charge density, unit is coulomb per meter. Third type, you take the capacitor plate, that is conductor plate. For this example is a transmission line conductor. Bottom conductor plate is there, then air medium is there, or dielectric medium is there. Then you connect some voltage source here. Then automatically positive charge comes here, negative charge comes here. This positive charge is distributed at every location. This negative charge is also distributed. Now, in this case, rho S, surface charge density, is defined. So how it is defined, I will write there. So third type of charge source is surface charge. That means charge is distributed on the surface. So let us take one surface like this, and on the surface at every location charge is there, distributed. डिस्ट्रीब्यूटेड मतलब हर जगह है, वो एक जगह में नहीं मिलेगा, और इधर भी लगाना है, इतना बहुत है. Let us take a total charge on this surface is total charge is equal to Q, and total area is A. Let us say total area is A, like total length is L, no, capital L. Now you select DS, differential surface, small surface. Then on that dq charge will be there. Now rho S is defined as limit del S tends to 0, del Q divided by del S. When charge unit is coulomb, this is meter square. Area means small surface, otherwise small area also you can write. This is surface charge density. Now this can be written as a limit del S tends to 0 means that surface is very small surface. If you take ds surface, then dq charge is there. So now you can write here rho s is equal to dq by ds. That means small charge is there, differential charge is there in differential surface. That implies dq is equal to rho s ds. This is one formula. In any question rho s is given, then multiply with ds. Then you get equation of dq, small charge equation you get. Now total charge is q is equal to double integral. You have to integrate this. How many integrals? 2 integrals. Why like that? Surface has 2 variables. So double integral rho s ds you get. This is the formula. Let us say this is equation number 2. So equation 2 like this now is used to find total charge when rho s is non-uniform. How do you know uniform, non-uniform? In the question they give rho s equation. If that rho s is a function of distance, then that is non-uniform. If that rho s is not a function of distance, that is uniform. If rho s is uniform, then q is equal to this rho s comes out double integral ds. That is nothing but rho s into this is total area. So now in this case q is equal to rho s into area. So this is the formula. Now here what is rho s? Rho s is the surface charge density. You have to remember the symbol and name and unit also. They are defined as scalars now. Rho L is defined as scalar. Rho S also is defined as scalar. Rho V also is defined as a scalar. So their students, because they are not moving, moving quantity, that is why not moving means doesn't have direction. That is the meaning. उतना डेप्थ में पता करने की जरूरत नहीं है. राइट स्टूडेंट्स, एक्चुअली हमको एक्सपीरियंस है इसलिए बहुत पढ़ लिया, बहुत एग्जाम्स क्रैक कर लिया, बहुत नॉलेज होता है. हर चीज नहीं पढ़ाना आपको, एग्जाम को जितना जरूरत है उतना ही पढ़ाना है. राइट स्टूडेंट्स, सो हियर rho s is the surface charge density. Unit is coulomb per meter square. Now third configuration, fourth configuration is the volume charge. Example, you go to the ionosphere. Because of sun rays, their positive ions, negative ions are separated. Second example, you take the diode. That means in ionosphere volume is there, in that volume charge is there. So second example, you take the diode, PN junction diode. So this is P material, this is N material, and near the junction in this volume you have charge carriers. So here you have negative ions, here you have positive ions. That means in this volume, for example, in this volume here, in this volume, charge is distributed everywhere. Here, positive charge. So their volume charge density is defined. In the volume charge is distributed means volume charge is defined, volume charge density. So these are the examples like diode space charge region, ionosphere. These are the examples of the volume charge. So anywhere in the volume charge is there, anywhere in the volume charge is there, then you can define volume charge density. The charge is distributed. You take small volume like this, then I am putting here charge is distributed everywhere like this, like this. In this total charge is let us say total charge is equal to Q. Then let us say total volume is V, let us say. Then in the small volume called dV, small amount charge dQ is present. That is common sense. In bigger volume, more charge is there. In small volume, small charge is there. Now definition. Volume charge density rho V is equal to limit delta V tends to 0. So delta Q divided by delta V. This is the definition. Coulomb per meter cube. Per meter cube means volume, so it is called volume charge density. Now delta V tends to 0 means that is small volume, that is called dV. So small charge is there in small volume, that is equal to dQ is equal to rho V into dV. This is actually one of the equation. Given rho V, then multiply with the dV equation, then you get dQ equation. Total charge Q is equal to, you have to integrate this one. Integrate means here charge dQ, here charge dQ, you have to add them. Add means integration. How many integrals? Triple integral. Why? Because it is a volume. So triple integral rho V dV. This is the equation. So let us call this as equation number 3. So equation 3 is used to find total charge Q when rho V is non-uniform. Rho V is non-uniform. What happens if it is uniform? In the given question, for example, first question is there, rho V is equal to 2x square yz, then find Q they ask, no? Then you have to use this formula, rho V dV, because it is a function of x, y, z. Second question, rho V is equal to 10, then find Q, then in this case, rho V comes outside because it is a constant integral. dV means then that is total volume called V. So many times I told you, if it is non-uniform, then it should be inside the integral. If it is uniform, then that is outside the integral. Okay? So if rho V is uniform, then Q is equal to rho V comes outside, triple integral dV, then Q is equal to rho V into this is total volume V, already written here. In this case, rho V is volume, charge, density, coulomb per meter cube. So dear students, in the intermediate you might have studied this as sigma S, but you forget about those symbols, because in engineering books whatever symbols are there we are studying them. In exam also we get same symbols. Then you study these symbols now, you will not be confusing in exam. Anyway students, whatever might be the symbol of this, rho S, sigma S, any symbol, but see the units now, then automatically name is decided here. Units coulomb per meter square, and it is a scalar, then definitely that should be a surface charge density, like that. Okay, so this is all about the types of charge sources. How many charge sources are there? 4. Point charge, line charge, surface charge, volume charge. Now we are going to study Coulomb's force law, then after that electric field. For example, you have to find electric field equation due to point charge, electric field equation due to line charge, electric field equation due to surface charge, electric field equation due to volume charge. So in that way, questions will be framed based on types of sources only. Questions will be framed. Okay. Coulomb's force law. Coulomb's force law. Actually, Coulomb did one experiment. Let us say here Q1 charge is there, Q2 charge is there, and distance between them is D. Otherwise, you can take distance is R also. D is distance between them. So now, D is distance between charge bodies. So, otherwise distance between charge sources. Okay, right. Q1 is first charge source, Q2 is second charge source. Actually, here like this, there is no connection you say, but distance between them is D actually, D. Now in Coulomb's experiment, he saw that Q1 value increased, measured force between them also linearly increased. So he decided F is proportional to Q1. Similarly, he increased Q2. Force, measured force magnitude also increased linearly. So he decided F is proportional to Q2. Then he decreased that by making these two constants, Q1, Q2 constants, he made the distance half. Then force became 4 times. Then he decided F is proportional to 1 by D square. Then ultimately here 3 parameters are there, Q1, Q2 and D. Then 3 are over. Then combined the results, F is proportional to Q1 and Q2 divided by D square. Then if you remove the proportionality, you have to put one constant actually. Actually this constant has to maintain the units, and this has to balance the measured magnitude also, measured magnitude of force also. Actually, if you take a sphere of radius r, then area of the sphere is 4 pi r square. If d is the radius, then 4 pi d square. Already here d square came, 4 pi is not coming in denominator, so in denominator 4 pi also has to come. Then if Q1 charge is there here, Q2 charge is there here, in between them air medium is there. That air medium has 3 parameters, namely epsilon and mu and sigma. Because of epsilon, electric forces, otherwise electric fields are transferred from one location to other location. So in this case, epsilon also comes in denominator. In case of magnetic fields, from one location to other location, because of permeability of the medium, magnetic forces or magnetic fields are transferred. So in this medium, if sigma is there, then currents are transferred. So in that way, that constant is taken as a 1 by 4 pi epsilon q1 q2 divided by d square. After taking this 4 pi epsilon, the measured value of force, experimentally measured value of force and theoretical calculation of force using this formula both matched, and then he released the formula and we are studying that formula. Now force is always a vector, but it is scalar form. Now we have to go to vector form of force. Before going to vector form of force, what is epsilon I will write. I told you anything is in the box, no? You have to study that. Here epsilon is nothing but epsilon naught into epsilon r. Epsilon naught is equal to 8.854 10 to the power minus 12 farad per meter. Otherwise, this is also 1 by 36 pi into 10 to the power minus 9 farad per meter. This is permittivity of air. This one. Now epsilon is total permittivity of the medium. Once again, farad per meter. For example, here in between these point charges, air medium is there, then that becomes epsilon naught only. If dielectric medium is there, then epsilon naught multiplied with epsilon r value of the dielectric. So here epsilon r is equal to epsilon by epsilon naught from this. It is ratio, so unitless, that is. And epsilon r is called relative. Relative means compared to air, how much extra is there. That is the meaning. Relative means. Relative permittivity, or otherwise it is also called as dielectric constant. For example, if you take any dielectric medium, then epsilon r value is 2, for example, then lifelong that value is 2. 2 is constant. That is why for that dielectric medium that is constant value, it is called dielectric constant. So it is unitless. Now frequently we need 1 by 4 pi epsilon naught value. So 1 by 4 pi. This epsilon naught here is 1 by 36 pi into 10 to the power minus 9. And this becomes 9 into 10 to the power 9. So 1 by 4 pi epsilon naught is 9 into 10 power 9. Now actually we want to vector form of Coulomb force law. Vector form of Coulomb's force law. Vector form. For example, let us say here Q1 charge is there. Where is that? In the space. Here Q1 charge is there in the space. Here Q2 charge is there in the space. Otherwise here Q1, here Q2 is there in the space. Now where is this? Let us say it is at location point 1. Where is this Q2? Let us say it is at location point 2. and somewhere at the corner you have origin. So Q1 is there, let us say it is at point 1 location in the space, and Q2 is there, let us say it is at point 2 location in the space. Somewhere here origin is there, let us assume. How do you know? Somewhere it will be there. We are assuming that it is the origin. Then from origin to P1 position vector, already we have discussed position vector. You go and see backside in your notes if you have any doubt. So OP1 bar means position vector of point 1 with respect to origin. Similarly, OP2 bar means position vector of point 2 with respect to origin. Now here from Q1 to Q2, if you draw a vector actually, that is R12 bar, that means R12 bar is nothing but point 2 minus point 1 in point form definition, or otherwise if you want in position vector form, that is OP2 bar minus OP1 bar. Okay, so simply it is written in point form, otherwise position vector form also. So point 2 minus point 1, you take the vector form, then you get R12 bar. What is R12 bar? Distance vector from point 1 to point 2. Then here I am writing a unit vector like this, A R12 bar. That means unit vector in the direction of R12 bar is R12 bar distance vector divided by modulus of R12 bar. So that is, otherwise I will write here like this. So that is A R12 bar. So A R12 bar is nothing but R12 bar divided by modulus of R12 bar. So dear students, every time writing this R12 bar is difficult. So simply I will make that as a A12 bar, or otherwise A12 cap. So A12 cap means a unit vector in the direction of R12. Because writing this every time is difficult, that is why. Now I am using this place. Actually, this is magnitude of the force. Okay. Now F bar means a vector. Vector is nothing but magnitude and direction. So magnitude is this one only. That means 1 by 4 pi epsilon naught epsilon Q1 Q2 divided by distance square. If you have a distance vector, then how you get a distance between them? You have to take the modulus of R12, then you get a distance between them. So that means here in place of d square mod R12 whole square you have to write. Then that is the magnitude, and direction is A12 bar, because A12 bar magnitude is 1 and it gives the direction. We should not change the magnitude, already this is fixed, this is the magnitude given by the Coulomb. So this notation we are giving like F12 bar, F12 bar. So what is the meaning of F12 bar here? Force vector, F means force, bar means vector, on Q2 charge due to the Q1 charge. So that is the meaning of that one. So dear students, now in the entire subject, in the total subject, like symbols meaning is same. F12 bar. F means force, bar means vector, force vector from point 1 to point 2, that is the meaning. So F12 bar meaning, F means force, bar means vector, force vector. Always on second one, force vector on Q2 charge, it is at point 2 due to Q1 charge, it is at point 1. It is at point 1. So now the formula is F12 bar is equal to 1 by 4 pi epsilon So Q1, Q2 divided by modulus of R12 whole square and A12 bar, that is nothing but 1 by 4 pi epsilon Q1, Q2 divided by modulus of R12 whole cube into R12 bar, because A12 bar is written like this, R12 bar by mod R12, then whole square it becomes whole cube newtons. So this is the formula which you have to remember. That means here Q1, Q2 by 4 pi epsilon R12 bar by mod R12 whole cube. Remember, here the unit vector is there, then whole square is there. Here vector is there, distance vector, then whole cube is there. So unit is Newton. So it is Newton, student, unit. So this is in Newtons. Now here already I wrote about epsilon. Q1 is first point charge, Q2 is second point charge. So A12 bar is unit vector in R12 bar direction. Then what is R12 bar? Distance vector from point 1 to point 2. So here R12 bar is equal to 0.2 minus 0.1 in point form. What are you doing with this notation? No, notation means symbol. With this symbol you are finding force on Q2 charge. So 0.2 means force location. Force location means at whichever location you are finding force, that location, minus other charge location. So this is our charge location. So dear student, what I am telling you is that if you want to find this is minus then 0.1. For example, if you want to find force on Q2 charge, then this is the source, charge source which produces force on that. So this is the other charge. So other charge is present at this location. So other charge location. What I want to tell you is that anywhere if force question comes now, no need to follow these symbols and all for objective questions. At whichever location you want force, take that point and subtract other point. Then you get R12 bar vector. Write that vector here. Take mod of that. Then whole cube that one. You get the substitute Q1, Q2. You get the force. So this is the R12 bar here. So you have to observe that also. Now dear students, F12 bar you have written. What is F21 bar? Then automatically it becomes minus of F21 bar, because it is vector, no? You have to take R21 bar for that. That is why minus of. What is the meaning of F21 bar? Force vector and Q1 charge due to Q2 charge. That is the meaning. Opposite of this one. Opposite of that one. Now let us solve one simple question. Let us solve one simple question. So on the force. So after solving one question, then always we will be solving electric field questions, because if you know electric field equation, then automatically force equation also you will know, student. Force equation also you can know. Later on I will tell you. Now here one question I am writing. Q1 is minus 3 into 10 to the power minus 4 coulomb is at 0.1 205, and Q2 charge is at 10 to the power minus 4 coulomb is at 0.2 1 comma 2 comma 3 in air medium. In air medium. So air medium is also called as free space, students. Then find force vector on Q2 due to Q1 charge. That is the question. Now let us write the answer. R12 bar is equal to, you want to force on Q2 charge, no? Then force location is 0.2, that is 0.2 minus of other point is this one, so 205. So dear students, be careful. On Q2 charge you want force, that location, that Q2 charge is at this location, that location should be written at the beginning. Then vector is 1 x value minus x value into ax, then plus y value minus y value into aya, then z value minus of z value into az. So then this you get minus ax plus 2aya minus 2az you get. Then R12 bar magnitude is equal to root of 1 square. Minus 1 square means 1 square only. 2 square. Minus 2 square means 2 square only. That is root 9. That is equal to 3. Now, this is the formula F12 bar. So, F12 bar is equal to now F12 bar is equal to 1 by 4 pi epsilon naught because air medium. Then it is, you can write here Q1 Q2 divided by 4 pi epsilon naught, and then R12 bar divided by modulus of R12 whole cube. So here Q1 is how much? That is minus 3 into 10 to the power minus 4. Then Q2 is how much? 10 power minus 4. Then 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Then R12 bar here is here no place, I will write here minus 3 into 10 to the power minus 4. Then 10 power minus 4, that is 9 into 10 to the power 9. Then R12 bar is that is minus ax plus 2ay, then minus 2az divided by 3 whole cube. 3 whole cube. So now you simplify this one. If you simplify this one, what value you get here? So here 3, here 3 square, 3 cube cancel. Then 10 power minus 4, 10 power minus 4, 10 power minus 8, here 10 remains. So minus 10 into minus ax plus 2ay minus 2az. That is nothing but 10ax minus 20ay and plus 20az. So you have to change the sign here. Minus is there, plus, minus, plus, minus. So it is fine. These many Newton's force is there on second charge. If you want F21 bar, na opposite of this one. Now, if they ask what is the direction of force on Q2, I told you in the basics, you should not forget any basic. I told you direction of any vector means you have to take unit vector. So direction of force on Q2 is equal to that is nothing but unit vector F12 bar by modulus of F12 bar. So that is F12 bar is 10ax minus 20ay plus 20az divided by root of 10 square, 20 square, 20 square. Minus 20 square is 20 square only. I think it becomes 30 student. So that is unit vector. No units are there. So that is direction of force on Q2. It is in this direction. Direction means unit vector actually. So I will tell you few more points related to this one. Now let us write some important points related to this. Note. First one, we know that F is proportional to Q1 and F is proportional to Q2. That means it is like Y is proportional to X. So Y is equal to some constant into X. So this is linear equation. That means Coulomb force is linear with respect to charge source. With respect to charge source. So Coulomb force is linear with respect to charge source. What is the use of this statement? Like in network theory, we use in a linear network, you use superposition theorem. In a linear network, superposition theorem says response means maybe current or voltage. Response in any location is equal to sum of individual responses due to each source. So like that, actually one thing, dear students, here now, okay, sound is not coming. So actually now, in our subject, like force equation, electric field equation, potential equation, any equation, all are linear with respect to their sources, because all the formulas now, for example, if I take voltage now, Q by 4 pi epsilon R, Q by 4 pi epsilon R. So here Q power 1 is there. You will never get root Q power 3 by 2 like that, you will never get. So always you get, always sources are in the numerator and power 1 will be there. That is always linear. So in entire subject, all the formulas are linear. And then what is the advantage of linearity? If you want a total force, for example, if you want a total force on Q3 charge due to Q1 charge and due to Q2 charge, then if you want a total force vector on this, then what to do? Assume that this is not there. Then find here force due to this one. Call that force as a F1 bar. F1 bar means force on Q3 due to Q1 charge. Similarly, find force on this due to this one. Call that as a F2 bar. So F2 bar means force on Q3 due to second charge source. Then total force on Q3 is equal to F1 bar plus F2 bar. This is superposition theorem. So dear students, this is applicable only if the formula is linear. I am telling you, in our subject all the formulas are linear. So this is the first point. And second point is that Coulomb force law is valid only if the distance between the charge bodies is much greater than the size of the charged bodies. So if the distance between the charged bodies, that distance d no, is much greater than the size of the charged bodies, it should be. Then, and also at least one charge body must be at rest. At rest मतलब नॉन मूविंग होना है, एक चार्ज कम से कम एक चार्ज बॉडी नॉन मूविंग होना है. If both charge bodies are moving, then the relative velocity must be much less than light velocity in that medium. मतलब अगर दोनों मूव हो रहा है चार सोर्सेस, देन उसका रिलेटिव वेलोसिटी है बहुत कम होना है लाइट वेलोसिटी से कंपेयर करके, उस मीडियम में लाइट वेलोसिटी से कंपेयर करके. Then you know that if positive charge is there Q1, this is also positive charge, then this is negative, then this is also negative. They also repel each other. So like charges means same sign is there. So like charges repel each other, and opposite मतलब unlike charge sources. So opposite like means same sign is there. So opposite charges, that means unlike charges attract each other. These are all experimental results, students. So if one positive charge is there, another negative charge is there, they attract each other. Here, actually here Q1 charge is there, then Q2 charge is there, then force between them is along the line joining the is along the line joining these charge sources. So it may be like this or it may be like this, but the force direction is along the line joining the charge sources. Okay, so force between the charge sources is along the line joining the charge sources. So these are the points, many things you know, but among them this is very important point. First one, Coulomb force is linear with respect to charge source. If so many sources are there, like this Q1, Q2, then find force due to each source and then add. Why I am stressing this much? In total subject, if you want voltage due to so many sources, you have to find voltage due to single charge source, then you have to add. Simply, if you want electric field due to so many sources, then you have to find electric field due to single source and you have to add. Because in all the formulas, charge source will be in the numerator, and in that power, one will be there. So that is why all the formulas are linear actually. Okay. Let us discuss the image theory. So this image theory is given by, this concept is given by Lord Kelvin. In 1938, he has given this concept. So before going to this concept, I will ask you one question from the previous problem. Actually, in previous case, Q1 charge was there at 0.1205 and Q2 charge was there at 0.2123. Then we found force on this, so due to this one. Then first step was finding the R12 bar, that is 0.2 minus 0.1. If we do not know these locations, if we don't know this location, any one of the location we don't know, then we can't find R12 bar, we can't find force, because if you want force value, you need distance. To know the distance, you must know locations also. If you don't know location, then you can't find the force. So that much you must observe. Then we will discuss what is image theory. Before going to image theory, you take one conductor like this, and this is one conductor surface. Like this, no? This is one conductor. Okay, very good conductor. What is the meaning of conductor? Every conductor has positive uh, conductor ions and then negative free electrons are there. So in a conductor material, that conductor atom releases the electron and that conductor atom becomes positive ion. So that positive ion is symbol like this. Then one electron is there here, minus sign, negative charge is there for electron. So we are showing with minus sign. So every conductor material atom releases free electrons and that atom becomes positive ion, so that if one electron is released by one atom, that atom becomes positive ion and which cannot move, and that negative electron can move. Like this everywhere positive ions are there in conductor and negative electrons are there in the conductor. Now this electron can move actually. Now, dear friends, what is the meaning of ground? So you see the earth, Jamin hai. So you dig up the earth, then pour water and put salt, so that the voltage of that becomes zero. So that is called earth, terminal otherwise ground. So आप लोग जमीन को खोद के पानी लगाओ और सॉल्ट लगाओ और उसका वोल्टेज जीरो हो जाता है, उसको ग्राउंड बोलते रहता है. Now what we do, if we connect this is, let us say this is ground here, this is the symbol. If I take one wire, conductor wire, then I connect like this, then the potential of this becomes zero because the earth potential is zero, so the potential of this is zero. So now this is the conductor surface actually. I will take one more conductor like this, dear students, one more conductor. Now you have to tell everything. What is the meaning of conductor? Conductor means positive ions are there, okay, negative electrons are there. Do you think positive ions can move? No, they can't move. They are in the bonding in a conductor material. Then negative electrons can move. So that means positive ions are there, negative free electrons are there, that is conductor. We are taking wire, conductor wire, and giving ground connection. Now what is the speciality of this ground connection? Voltage is maintained zero here, voltage is maintained zero here. That means this conductor surface potential is zero, this conductor surface potential is zero. Now this ground has one more speciality. If this conductor surface don't want electrons, listen carefully, if this conductor surface don't want electrons, if this conductor surface does not want electrons, then these electrons are received by this ground. Similarly, if this conductor surface want more electrons, then this ground can supply the electrons. So that is the discussion. Now what we do, if I put positive charge, this is conductor surface, if I put positive charge here like this plus Q charge, then what will happen? This positive charge attracts electrons because positive charge attract negative charge. So here plus minus neutral it is. Neutral means I am removing this. So this is also neutral. This is also neutral. That means this charge surface is neutral. This conductor surface is neutral now. Now this positive charge attracts the electrons, but here plus minus, everything is neutral. So now electrons start coming from ground actually. Excess electrons, that means extra electrons. One electron comes here, second electron, simply I will show electron sign as minus, second electron here, second electron, third electron, fourth one, fifth one, like this. Like this, how many electrons? Oh, so many electrons, millions electrons. For example, if I take this is 1 coulomb, then 1 coulomb, total charge is equal to n into charge of electron. So n is equal to q by charge of electron. If you want 1 coulomb charge, then electronic charge is 1.6 into 10 power minus 19. That is 10 power minus 19 plus 19 divided by 1.6. These many electrons will come. That is so many electrons. So so many electrons are there. These electrons are distributed on this surface. So then, what is the charge of this total electrons? That is minus q. For example, if I take this charge at h height, then I will take this as a z-axis. I will take this as a z-axis. Then wherever conductor surface is there, I will take that as a starting height. So I will take this conductor surface height as a z is equal to 0. Now then definitely this is z is equal to h. So this location is 0, x value 0 on z-axis, y value 0, height is h. For example, if I take this as a 0.2, so I know this location now. But what is the total charge here? Minus q. Do you know location? No, you don't know. Why? This is distributed on this surface, so you don't know the location of this. Now, if I ask you to find the force on this one due to this negative charge, we cannot find because we don't know the location of this charge. Actually, according to Lord Kelvin, this is infinity area conductor surface. This is infinity area conductor surface, dear students. Infinity area conductor surface. So on that infinity area conductor surface, this charge is distributed. So we don't know the location. Now, Lord Kelvin gave equivalent charge diagram. We will discuss that one. Now, similarly, student, our conclusion is near the conductor surface, near the grounded conductor surface, if a positive charge is there, then automatically here negative charge is induced. Induced means newly produced. Now let us discuss this. Here, if I put negative charge here at h height, then automatically this negative charge repels the electrons, repels the charge carrier. Now this negative charge repels this electron, it can go away. But this negative can attract this positive, but that positive ion in a conductor cannot move. It is at fixed location. They are in the bonds actually, metallic bond. They can't move. I told you already, electrons can go to the ground, or electrons can come from the ground because they only can move because they are called free electrons. So these negative charge repel these electrons. They will go away. So that positive ions are there. That means total charge here is plus q charge, equal in magnitude and opposite in sign. Now conclusion is that nearby a grounded conducting surface, if you put positive charge, then a negative charge is induced. Induced means newly produced. Similarly, nearby a grounded conductor surface, if negative charge is there, then positive charge is induced on that. That is the concept. Now, let us write this one. What is the problem here? I told you if you want force on this, due to this negative charge, you cannot find force because this charge is distributed. You don't know the location of this. So, that is why we have to first, whenever charge is nearby the grounded conductor surface, then you have to draw the equivalent charge diagram, and then you have to find the force, etc. Okay. So now according to image theory, if there is one conductor surface like this is very big conductor and you can see only top surface. this conductor is grounded here, and this is actually infinite area grounded conductor surface. Actually, it is solid conductor, student. Anyway, this is conductor means solid conductor, but only top surface is visible to you. वो दिखता है, ये कुछ नहीं दिखता है. कंडक्टर के अंदर क्या है, कुछ नहीं दिखता है. Now, on this, how much charge is there? Answer: zero charge is there, because neutral it is. Any conductor is neutral, because one positive ion, negative electron, positive ion, negative electron. Now it is neutral actually. So free electrons are there, positive ions are there, in such a way that material is neutral. So now you can remove this. Now if I put here Q charge at h height, that means if I take this as a z axis, then this location is 0, 0, h. Then automatically, because of this positive charge, here negative charge is induced. Students, before putting this charge, there is no charge here. But when you get this positive charge near the conductor, then automatically here negative charge is formed. How much negative charge? Total negative charge. Total charge is minus Q. Here total charge is minus Q, but it is distributed on the infinite area surface. We don't know the location, but what is the potential on this surface? 0 volts. Now, Lord Kelvin says you can draw the equivalent charge diagram. So, according to image theory concept given by Lord Kelvin, image theory concept, equivalent charge diagram is actually what Lord Kelvin says. You put the charge itself. Now, first step is, that is not the first step. For example, here the conductor is there. Where is the conductor surface? Conductor surface is this one. Then wherever conductor surface is there, that is the starting height, that is taken as z is equal to 0 height. So now this is z is equal to h. For example, conductor is here, this is z is equal to 0 height. From this height you have air medium here. हवा है इधर. So इसको बोलता है z is equal to 0 height. If conductor is here, then this is z is equal to 0 height. Then height measurement starts from this location. So first step is give the location of the conductor surface. Then answer z is equal to 0 is the location of the conductor surface. What is the area of that? Infinity area. It is like this, infinity area. Then this surface from front looks like a line. It looks like a line. So draw a line here, but it is not a line. It is in the equivalent diagram. In place of conductor surface, you remove the conductor surface, then you imagine infinite area surface here. What is the material? No material, it is imaginary. Then that is nothing but xy plane. Z is equal to 0 means xy plane. Here x-axis, y-axis. So xy plane is there. XY plane of infinite area. Z is equal to 0 plane means xy plane only. So it is imaginary. What is the material? No material. Then why are you taking for reference purpose? Which reference? Conductor surface reference. So here is the conductor material. Then this is the conductor surface. At Z is equal to 0 height, it is there. So now in the equivalent diagram, simply draw a line that is for reference purpose. That line is nothing but surface, because if the imaginary surface, that is xy plane, from front it looks like a line. Line is drawn, but it is actually xy surface of infinity area. Now you put the charge here in such a way on this imaginary surface, you must get 0 volt, because earlier there was a 0 volt on the surface. Then the image diagram will be over. If you don't get 0 volt on this imaginary surface, then charge diagram will not be over. You have to think of to put more charges so that you get 0 volt there. That is the image theory concept. So now what to do? You put here charge itself, then at this much height, then bottom side again at h height. Actually this is z0, this is called as z is equal to plus h, this is called as z is equal to minus h. So the location becomes 0, 0, minus h, but magnitude of the distance is h only. Magnitude of the distance is h only, but location wise, bottom side means you will write minus h. So here you will be putting negative charge, that is opposite of that one. Here plus q is there means minus q you have to put. Here minus q is there means here plus q you have to put. This is called charge itself. मतलब जो charge है वही है. So charge itself, and it is called image charge. Image charge. Then automatically you get 0 volt here. So dear students, voltage due to point charge is 4 pi epsilon r. 4 pi epsilon r. What is the potential here? If two charges are there, then find potential at this location due to this charge and due to this charge. Due to this charge, potential here is q divided by 4 pi epsilon, distance is h, plus find potential here due to this charge, minus q divided by 4 pi epsilon, distance from here to here h, so potential becomes 0. So conclusion is that now I am asking questions. Here top side what is there, bottom side what is there. Here top side plus q charge is there. Here bottom side conductor is there. But here for example air medium is there. Now in this diagram, top side what is there, bottom side what is there. Answer: top side positive charge is there, bottom side image charge is there, but here nothing is there. Simply that is a reference line, and there is no conductor material here. That conductor material was removed here, and just a reference line is drawn here. So to maintain 0 volt here. Now here also air medium is there. Here also air medium is there. So if dielectric is there here, then here also dielectric is there. Here also dielectric is there. So now what is this actually? XY plane of infinite area having 0 volt. Okay, having 0 volt. So that is the what do you say, image theory statement. Now anybody ask you to find force on positive charge, now you can find, because you know the location of this and you know the location of this also. So you can find the force. Now briefly I want to tell you one point. When will you complete the image? When will you complete the equivalent charge diagram? Answer: you take the original charge and adjust the charge here in such a way wherever conductor surface is there, at that location you have to get 0 volt. So in case of parallel planes, if the conductor surface is parallel plane, then just above this, just below this, at equal distance, put equal magnitude of charges and opposite sign, then you get 0 volt. But if conductor surface is spherical surface, then you can't get 0 volt by taking equal height, equal magnitude and opposite sign. We will solve one question, you will understand. So my dear students, once again I am telling, what is the shape of the conductor surface? Answer: parallel plane. Is it a curved plane like this? No, it is parallel plane like this. Then in equivalent diagram, where you have to get 0 volts? Answer: wherever conductor surface is there you have to get 0 volts. Then do you think here conductor surface is there? Answer: no conductor surface. Then what to do to get 0 volts here? Above this, if positive charge is there, below this you have to put negative charge. In case of parallel plane, at equal distance, equal magnitude of charge, opposite sign is there, then you get 0 volts here. Then image diagram will be over. So now I will write the statement here. I will write the statement. When image theory is applied, whenever any charge source is nearby the conductor surface only, otherwise you should not apply. Okay, anywhere if conductor surface is there, nearby that charge is there, then only you have to apply the image theory. I will be writing that here. So image theory states that the Q charge nearby a grounded conductor surface is replaced with charge itself, that is plus Q, and its image charge, that is minus Q, in such a way, this is important, in such a way the conductor surface, that means this conductor surface is replaced with 0 volt imaginary surface. Imaginary surface means here there is no surface physically, nothing surface, just imagination. The shape of that should be the shape of this conductor surface. The shape of this conductor surface is the top surface, that is parallel plane. If it is a spherical conductor surface, then here also you have to imagine a spherical conductor surface, and then you have to put the charges in such a way on that imaginary spherical surface you have to get 0 volt. In that case, you can't take equal height, equal magnitude. Further derivation is there, I will tell you, one question is there. So this is the concept, 0 volt surface, but it should be imaginary surface. Okay. Now, one more note I will write here. Students, sometimes this conductor surface in the questions, this diagram also given like this. The stock conductor, uh, from front you see it looks like a line, like this it is kept. Then ground connection it is shown like this symbol. Now Q charge is kept like this. They write here conductor surface they will write. Okay. If it is a perfect conductor, for a perfect conductor sigma is infinity, and then infinity sigma means resistance is equal to 0, then voltage is equal to I into R, I into 0. Automatically voltage on that perfect conductor is 0 actually. So sometimes they will write, they may not ground, but they will write perfect conductor surface. Anyway, near the conductor surface if charge is there, automatically you have to apply the image theory concept. Actually, no student, I want to tell you one statement. In the logical experiment, they kept Q charge here at h height. Then they measured the force using force meter. For example, let us say they got 25 Newton. Then in this diagram also, using force meter, if you measure the force here, you get 25 Newton. Force here, due to this charge, you will get 25 Newton only. In that way, that is why this diagram and this diagram both are equal. Just I am telling you the explanation. Okay. Now, let us write one more point here. For example, if this is one conductor surface here, like this it is, then from front it looks like a line. So this is conductor surface, grounded. Another conductor surface is there at some angle, then it looks like a line. That is also grounded. Then how many conductor surfaces are there? 2. Then angle between them is theta degrees. Then you put Q charge between them. Then how many image charges will be there? For example, in this question, how many image charges are there? 1 image charge is there. Total number of charges are 2. Out of 2 charges, one is original charge, another one is image charge. So here, now, if 2 semi means half, 2 semi infinite area conductor surfaces are at theta degrees angle, then the number of image charges is equal to 360 degrees divided by theta degrees minus 1. So this is the formula. Example 1 I will take. So like this it is given. One conductor surface like this. Only from 0 to infinity it is there. It is called semi-infinite. This side it is not there. It is 0, y0 for example. Up to infinity it is there. But this side nothing is there. And again second conductor surface from 0 to height up to infinity it is there. So this is another semi-infinite conductor surface. Only front line you can see, front is drawn. So these are conductor surfaces. They are actually semi infinite area, conductor surfaces, both, na? Both, that also, this also. Now here some charge is there, Q. Then in this case, number of image charges is equal to. Then answer, dear students. Here the angle between them is 90 degrees. So use this formula now. 360 degrees divided by 90 degrees minus 1. 4 minus 1 is equal to 3 image charges in this case. So example 2 I will write. Example 2, this one only. For example, if this is given like this and Q charge is there, then this is conductor surface grounded. So dear student, what is the meaning of this? You know, actually here nothing is given means it is going up to infinity. Here nothing is given means it is also going up to infinity. It is infinity area surface. So this one. Now how you get this one? Actually, let us say here I don't have two pieces. So this is one semi-infinite area surface you take. This is also one infinite area surface you take. Angle between them is how much? 90. Now, like that they are there. You again bring this like this. Now this looks like a single line. Now you can treat this as a two semi-infinite area conductor surfaces at 180 degrees angle. So only front view is shown here. So now in this case, here this one is angle between them is 180 degrees. So it is like this question only. So here number of image charges is equal to 360 degrees divided by, this is one infinity area plane is nothing but two semi-infinite area conductor surfaces at 180 degrees angle. So that is why 180 degrees angle minus 1, that is 2 minus 1 is 1. Yes, this is only one image charge in this case. So this is the second example like that. Now actually I will solve the questions so that you will get more clarity. Okay, so once again, dear students, when will you use the concept of image theory? States that Q charge is nearby conductor surface. That is very important. If charge is not nearby conductor surfaces, then charge is not induced on the conductor surface, then no need to take image charge. Okay. So students, in image theory, if you see the electric flux lines shape, it is like this. This is the conductor. It is grounded here. Now, if you put here no charge is there, now it is neutral. If you put the positive charge here, it is like a very small sphere at h height. What will happen? Then electric flux line start. Example I am telling. For example, here there is a bulb, let us say. Here there is a bulb. Then if I send the current through this, then light rays radiate normal to this. Normal means perpendicular in every direction. So These are called light rays or otherwise light flux, FLUX, flux. Flux means flow actually. If light quantity flows मतलब जाएगा, दूर जाएगा. If light quantity flows, that is called light flux. If electric quantity goes, that is called electric flux. If magnetic quantity goes, that is called magnetic flux. If temperature effect, for example, you take one iron rod, then you increase the temperature of that so that it becomes very red. Then it releases the temperature, so that is called temperature flux. So flux means flow. Some quantity is moving. So, but here light rays are visible, but all quantities are not visible. For example, experimentally it is observed that whenever a positive charge is there here, around that, like a light rays in every direction, electric flux lines are released, but they are not visible. You can feel them. How can you feel? For example, wherever electric flux line is there, there you put one negative charge. This positive charge attracts that negative charge because these electric flux lines will be going there. That is why. So this electric flux lines, the symbol is psi. We will discuss that later on. Don't worry. Electric flux symbol is psi. These electric flux lines keep going away. Now, whenever you put the positive charge nearby the conductor surface, then electrons come in here and they accumulate here like this. Now these electrons actually they attract this flux going from positive charge. For example, now bulb is there, and if I give the current, now light rays go, then any black object comes. So some black object comes, then this what do you say, light rays end on this black object, then they can't go beyond that absorbs. Similarly here, the positive charge, positive means generate, negative means absorb. पॉजिटिव मतलब जनरेट करके दूर भेजता है, नेगेटिव मतलब खत्म कर लेता है. So now this electric flux line is going like this. This negative charge absorbs that one. This electric flux line is going like this. This negative charge bends that one. So like this it bends. Similarly, these are all the electric flux lines. They end on this what do you say, negative charge surface like this. So they bend and they end here like this. So that is why Lord Kelvin has taken infinity as a surface, because these light rays go and bend at infinity, they end here. So now if you see the equivalent charge diagram of this, what is the equivalent charge diagram of this? Like this, no? Equivalent charge diagram. Equivalent charge diagram. Equivalent charge diagram क्या होता है? So here Z is equal to 0, that is reference line, having 0 volts here plus Q, here minus Q like this. Now in this case also what happens? This from this positive charge, electric flux lines go away in every direction. Then if this line is going like this, then this attracts that one. So that is why this comes and end here, and this also bends and end here like this. They come and end here. So like this. Okay, dear friends, like this they will come and end here. Okay. Conclusion. What is the role of this positive charge? Answer: it generates electric flux. Here, what is the role of this positive charge? Here also it generates the electric flux. What is the role of conductor surface? It absorbs that flux. What is the role of negative charge? It absorbs that. So here positive charge role is played by this positive charge only. Here conductor surface role is played by the image charge. So in that way, both diagrams are equal. So one objective question is there, later on I will tell you. Here electric flux lines will be there like this. Here also electric flux lines will be there like this. If electric flux is there, here also is there, here also is there, here, then if electric flux is there, then electric field also is present. This is called electric dipole. One positive charge is there, negative charge is there, separated by some distance. That is called electric dipole. So around the electric dipole, everywhere electric flux is there. So everywhere electric field also will be present. Electric field value is not zero around this. This is standard question. We will discuss that later on. So here H height, here also H height. We will talk about that later on. Don't worry about it. This is the shape of the electric flux lines. So they also come like this, and they also come and end here like this. Okay. So like this they come and end. Now let us solve some questions based on image theory. How do you recognize image theory questions? There should be a conductor surface. There should be a conductor surface. Okay. Now I am removing them. Okay. So the question number is 43 for regular batch students. For GATE students, it is question number 37. Okay. So I am not writing the entire question. So simply question I am telling. Actually, this is the semi-infinite area conductor surface. This is another semi-infinite area conductor surface. It is given like this. Then here you say plus q charge is there. For example, let us say it is at d distance here. From here also at d distance plus q charge is there. So in the question it is given they are conductor planes. This one also conductor, this one also conductor. So conductor plane means conductor surfaces actually. Now, which of the following is the equivalent diagram? So you have to draw the equivalent charge diagram. So you have to draw the equivalent charge diagram. So that is the question, students. Okay. Now what image theory says? What image theory says? For example, you take this as a x-axis, or otherwise you take this as a y-axis, you take this as a z-axis. Okay. Now here how many conductor surfaces are there? 2. This is semi-infinite area conductor surface. From front it is shown like a line. Now this is the starting point. Let us say I will mark here that one. Now just I am drawing the simple line here, that is imaginary line, and this is also one line here, but actually they are surfaces. One imaginary surface like this, other imaginary surface like this. Now image theory tells you that remove this conductor surface and imagine one surface there, no material, just above this. Put the charge itself at a d distance. Then here below this you have to put minus q charge in such a way here you get 0 volts. Now Here once again, one more conductor surface is there, you remove that. Whenever conductor surface is removed, at that location you have to get 0 volt. To get 0 volt, one side positive charge should be there, and again exactly at d distance, other side negative charge, that is image of this, should be there. Now if you see voltage here, you must get 0 volt, but now you did not get 0 volt because negative charges are 2, positive charge is 1, negative charges are dominating. You will not get 0 volt here, you will get negative voltage. But according to image theory, in equivalent diagram, wherever conductor surface is there, for example here, wherever conductor surface is there, for example here, you have to get 0 volt. Now how much voltage is there here? Answer: voltage at this location is equal to voltage due to discharge, that is Q by 4 pi epsilon, distance from here to here. This is d, this is d. Then this is hypotenuse, root of d square plus d square is root 2d. So root 2d. Potential here due to this one, minus Q divided by 4 pi epsilon, distance from here to here is root 2d. So potential here due to this one, minus Q divided by 4 pi epsilon root 2d. I told you every point is linear, so potential at this location is equal to sum of the potentials due to discharge source, discharge source, discharge source. Now this cancel, you got this value, so it is not 0. So what to do now? You have to extend the diagram. Now opposite to z-axis, no, I will take negative z-axis. Opposite to this, I will take negative y-axis. I will take. Now you may have to put the image of this charge, or otherwise maybe image of this charge, any one of them. Then diagram will be completed. For example, at d distance here, at this side also, opposite side also, d distance I will take here. Then for minus q, image charge is again plus q. For this charge also, image charge will be plus q only. So in that way, now the diagram is completed. So dear students, now if you want voltage here, then answer is 0 because 2 negative charges, 2 positive charges. So this is image of this one, this is also image of this one, and this one is maybe image of this one or image of this one. Now this diagram is completed. Already we have solved one question. How many number of image charges are there? Answer 1, 2, 3. This is original charge only. If you want, you can give the locations also. For example, this is YZ plane. On YZ plane, x value is 0. So x value is 0 on YZ plane. X value 0 on YZ plane. Next, for this y value is positive. For these two, y value is positive. And for these y values are negative actually, minus d, minus d. For top points, z value is positive, that is d. So this is also d. For bottom values, z value is minus d actually, students. So these are the locations. Even if you want force, no, you can easily find because you know the locations. So this is the answer for this. I think this is in option D actually. This is an option D, dear students. So now let us solve one more question here. That question I will write here. Okay. So you need it.